Kate. Really appreciate it. As Kate mentioned earlier this year, I had the opportunity to make the transition from board member to management team, and I'm now 52 days into the job. And the question that I keep getting all of the time is, was it a hard decision? And the answer I keep giving everybody is, it's the hardest, easiest decision that I ever had to make. It was hard because, one, I was leaving a company I loved, a brand I loved working for. Two, I was rolling off the board, and I'll tell you, for the last 2 years, it has been a very interesting point of view to have, to be able to watch the transformation that Kate talked about in the role of governance on the board of directors. But the easy part of it really kind of boiled down to three things. One, this is a spectacular management team. I can't tell you how well they work together and work off of each other. It feels very much like a startup mentality and how they're thinking about the way the company gets run. The second is the culture of the company. Kate and the management team have really kind of taken this old telecom mentality and they've taken it out of the organization. When you meet the leaders across the organization, what you're going to find is people who are passionate. They're passionate about change. They're passionate about what they see the opportunity for. But the third is kind of what Kate alluded to. After 30 years in enterprise tech, 20 years in some various role as either a CTO or a CIO in lots of different industries, the problem couldn't be more clear to me. Like, I see it. Like, I was experiencing it as an enterprise technology leader. My first CTO role was 20 years ago, and what seemed really complicated to me then is actually not that complicated. All of my applications and my data sat in 2 data centers. Those data centers were about 300 miles apart. If one failed, the other took over. All of my users sat in about 100 locations around the world. They were connected by T1 and T3 lines back into those data centers. We had firewalls that protected us. The perimeter was actually pretty easy to manage. But I would say all of that has changed in the past 10 years for the enterprise. The perimeter now is the whole of the internet. And it's really driven by a few things. One, there isn't one enterprise leader who hasn't moved to software as a service. Their CRM is sitting in Salesforce. Their ERP is sitting in SAP and SAP's cloud environment. They're running MRP systems that are running in other companies' data centers that manage them for them. SaaS really started to expand the perimeter of the data and the applications that enterprise leaders have to manage. That made it more difficult. Those 2 data centers I talked about, we moved them to the cloud, right? So now they're not just sitting in 2 data centers, they're sitting in 20 data centers. And by the way, not just one cloud, they're sitting in AWS, some combination of AWS, Azure, and GCP, depending on the workloads that you were trying to move. Again, the perimeter kept expanding. That workforce that sat in those 100 locations, well, now they're sitting in 20,000 locations because they're a hybrid workforce and they're working from home periodically. And so that increased the edge of what you had to protect and how you had to think about data movement. And then I mentioned it was a global organization. When you think about data sovereignty laws requiring you to keep data around the world, this perimeter issue really drove the problem that Kate unpacked for you earlier, which is AI-driven proliferation is real. Data is sitting everywhere. Apps and data and users are widely dispersed. And as an enterprise technology leader, that was a core problem that I was faced with. How do you manage every day? As the perimeter expanded, the second thing that really happened is you ended up with the proximity issue of how you thought about data. From a proximity perspective, the perimeter breakdown really means that data, which is really the fuel for business, is distributed everywhere. The days of having compute and data together, like those 2 data centers, I could have the data and the compute sitting next to each other, those days are over, and they're never coming back to us, quite frankly. Compute and data are going to be sitting at the edge, and the value of investments that we're making in things like artificial intelligence, they're really being throttled by the public internet, because that's really the way we've been connecting the data and the compute together as it sits in different clouds and different data centers around the world. And those hybrid architectures, they're not going away. They're only going to get more complicated, and they're only going to continue to grow. So the third problem that I clearly saw as kind of an enterprise technology leader is one of reliability and resilience. There was a day last year where one of the major cloud providers had an outage in a region. We couldn't book product for the day. We couldn't service products for the day. So think about the complexity change that happened in 20 years from a resiliency and a reliability perspective. All my apps, all my data set in 2 data centers fail from one to the other. Pretty simple. Well, today, a business process, not even a system, a business process can span multiple data centers and multiple cloud providers. And how, as an enterprise leader, as an enterprise technology leader, can you really manage that? Those are some of the key problems. And frankly, it was the key problem that I could see that really made it so easy to say yes to Kate and the management team. So Kate, thank you for calling. It's going to be a fun ride. And you don't have to look far to see examples of this playing out today, data that you can look at to see this happening. The first one I'll call out is data center growth. Over the next 5 years, we're going to see a 10x increase in the number of data centers located in the United States as we build out the capacity for artificial intelligence in the world that we see coming at us. Those data centers are not going to be in the same space as the data centers are today because they're going to follow the 3x increase in power builds that are going to move to rural America. They're going to move to where there's fuel, where there's capacity, and where there's land, and where there's tax abatements. And that perimeter that we've been talking about is going to continue to get worse as a problem for enterprises to really think, how do you manage this dispersion of data and systems and processing? The second is one of cost. I have a friend who's a CIO of a large bank, and I was talking to them about what they're doing to build their own large language model. They're one of the few enterprises that I see doing this, but they recognize they've got 20 years of data about their customers, about the transactions they've made, and they believe that there's a financial planning capability that they can build in a specialized model. And the problem that this CIO is faced with is to be able to get to the GPUs, which are in short need, they're having to go to neo-cloud providers that are providing GPU as a service. Well, that's not where their data's at. And so here they are, they're paying $2,000 an hour for these chips to be able to build this model, but they got to bring petabytes of data from their data centers to get there. And so the problem they're faced with is the CPUs, the GPUs that they had to pre-reserve to be able to get them are sitting idle at $2,000 an hour. So we just kind of give you a quick example here. If you think about moving a petabyte of data over what most companies have traditionally had, a 10 gig circuit, that's 222 hours. That's 222 hours of potential downtime for that CPU while you're trying to get the data to the GPU to actually train it. So this is why you're going to hear us talk about the need of the future is around high bandwidth, getting to 400 gig circuits, 800 gig circuits, 1.6 terabyte circuits. It reduces this from a 222-hour problem to a 6-hour problem, and that's worth almost $500,000 of savings from a GPU cost perspective for that one customer in doing training. So cost, you're seeing this start to unfold as a big issue in idle time within the infrastructure driven by the capacity limits of the network. And then the third thing you're going to hear more and more about, right? We're at this point where companies have moved on from experimentation of artificial intelligence to implementation. Latency is going to matter so much. One of the biggest examples when I talk to my peers in the technology industry that most enterprises are going after is the call center. There's a lot of great new technologies that can be that first call receive, either a text or a chat or a voice call. This isn't the voice systems of the past 20 years. This is going to seem and feel like you're talking to a real person that's able to talk to you. And you're going to have this issue of inference that's going to come into play. For that application to matter, for that virtual agent to be able to talk to you clearly and plainly and be able to converse at the speed that you want to converse at, it has to be able to infer and get data from the rest of the system that's spread out. If that doesn't happen for voice applications at a 5 to 20 millisecond level, it's not going to feel real and it's not going to work. Think about all of the different applications here. Image recognition, 50 millisecond cycle time. You go to some of the more advanced capabilities like telesurgery, drones, and robotics, you've got to be under 5 milliseconds. It's one of the big reasons that from a Lumen perspective, we've been really focused on making sure that our network is within 5 milliseconds of 85% of the hyperscalers of the data centers inside the United States. Latency is going to be the third big problem that enterprises are going to feel that they're going to need a new network, a new way of thinking about the network to be able to deal with. So when Lumen talks about Cloud 2.0, this is what we mean. It's about helping customers unlock these value levers. How do they get to scalability without runaway cost, right? That first bucket. How do they get to bandwidth that keeps the GPUs, the XPUs, all of the new processing unit types for being productive and from being idle? And how do we get latency that is really low enough to enable an entirely new class of artificial intelligence-driven applications? This all starts with a network that's high bandwidth, that's low latency, and that it's programmable by design, that's resilient and ability for our customers to be able to control that world. Now, Kate talked about supply and demand, and she started to define kind of two markets that we're focused on within Lumen, and I want to make sure everybody understands these two markets. The first we'll talk about is kind of the north-south. Think about north-south as an enterprise connecting their premises, their buildings, to their data centers, or to their cloud, or their premises connecting to each other. This is the complex version of the world that I described I was in 20 years ago. It's not new. It's about a $12 billion TAM for us. It's not growing, but it is getting far more complex. Whereas 20 years ago, I was connecting a set of buildings together within 2 data centers that I own, I now have to connect into 20, 30 different data centers, to the SaaS providers, to the hyperscalers. The complexity of the north-south is getting bigger. The market itself, though, is not. The second market, the one that's the really interesting market for us, is east-west. As the world generates more data, as data becomes the fuel for business, as we think about what's sitting in the data centers and the hyperscalers, the east-west traffic of moving petabytes of data back and forth between hyperscalers to neoclouds, between neoclouds and on-premise data centers, that's where a lot of the growth is going to be. We believe this is an $11 billion TAM for us today. It's growing at about a 13% CAGR. We expect this to be a $20 billion TAM for us by 2030. This is where AI training and inference really matter because you're moving really large amounts of data around. And what's important for all of you to understand is that most providers are focused on one or the other. They're either focused on that north-south traffic and how do I get my enterprise and my customers' enterprise connected to the cloud, or there's a set of companies that are focused on cloud to cloud. Very few are building a platform that's designed to serve both markets. Cloud 2.0 is Lumen's answer to that. We're building a network architecture that addresses both enterprise to cloud and cloud to cloud connectivity together at scale with the bandwidth, the latency, and the control that these workloads demand. Now here's the rest of the story. I told you that the north-south is static. It's not growing. But we also believe is the winner on east-west is going to take share from north-south because what enterprise, right, this is me, the customer 53 days ago, what customer wants to have to go to multiple providers to deal with the end-to-end issue that I have as an enterprise? So from our perspective, winning east-west is also about taking share from a north-south perspective. That's something I want to make sure everybody understands about our strategy here. So now the fun stuff. This is the stuff that I geek out about. This is where we get into the how do we make it work. This is our roadmap. How are we doing this? This is the roadmap that we're going to really make Cloud 2.0 real. In 2026, we'll invest about $500 million really to build a truly programmable network for AI-driven workloads. And we're doing this across 3 really tightly integrated layers of building blocks, and Kate kind of took you through this. The first is the physical network. We talked about large capacity, low latency networks. We need to do this at the inner city level. That's our rapid routes work that we're doing to get 400 gig circuits across the United States. Once you've built inner city, you need to do within city. That's our metro work, where we're doing a metro network that is able to support high-speed Ethernet within the individual metro areas where our network exists. And then you've got to get it out to the data centers. How do you make sure that you can go from the metro to the data center, again, with that 400 gigabit band circuit? All of that supporting the work that we're doing to get to the cloud on-ramps, the AI on-ramps, and making sure that we can get that enterprise connectivity from a wing-to-wing perspective in place. We started, if you recall, with the PCF deals. That was about helping the hyperscalers to be able to build out the large language model capabilities within their clouds. What you see is the building blocks above that are what we Lumen are building out for our enterprises to be able to get their data to and from. This is a very much a homogeneous relationship between what we've done with the PCF and what we're now doing at the enterprise level to build out the physical network. Taken together, the second part of this is the digital platform. Once we've given the physical network, we want to give control to our customer. It starts with how we go to market. That's network as a service. Again, you heard our successes this week. We crossed the 2,000 port number as network as a service. That is the motion that we will go forward to have one port and many services. To make that work, we're building a platform called Lumen Connect. Lumen Connect is that digital skin that we're giving to our customers to be able to own their own connectivity, their own service addition and modification, to be able to manage the network much the way they manage the cloud. The third is the fabric port. This is the physical device and the network components that make it happen, that allow this all to get connectivity together. And then multi-cloud gateways is a way to give customers a one point of connection into all of the clouds, all of the SaaS providers that we're building to make it easier for them to not have to build individual connections. And then once we've got the physical layer and the digital layer, the platform together, we know that we have partners that need access to this same level of connectivity. So through Lumen validated designs and marketplaces, being able to use the underlying platform that we've built to allow our customers to get connectivity in. Taken together, this is how we turn the network into a programmable asset, a platform, one that supports both enterprise and cloud core use cases, both north-south and east-west. It scales with AI demand as we go forward, and it really lets customers consume connectivity the same way they consume compute and storage in the cloud. All of the benefits that I got as an enterprise leader of moving to cloud from a time to market perspective, we want to provide at the network layer as well. And so I'm going to drill into a few of these just to kind of give you an idea of where we're at. The first one I'm going to start with is rapid routes. This is where we're looking intercity across the US. How do I make sure that I've got 400 gig circuits that run across the United States? The progress we've made, we've got 36 new routes. High speed, can spin them up in just a matter of days for customers to be able to get 400 gig intercity capacity. By the end of this year, we'll grow that to 49 new routes, and we'll expand 18 additional routes to have that 400 gig capacity to be able to move large amounts of data between cities across the US. So now you've landed in a city. We've got to make sure we're doing it there. That's our metro expansion. Metro expansion is where we're providing high-speed Ethernet services in key metro markets where we know a lot of these AI-enabled growth is happening. Today, we have 6 gateways in 6 markets, and by the end of this year, that's going to grow to 35 gateways, 32 markets. It'll be in over 248 of our wiring centers around the United States. So this is, once you get in the metro, how do I get to your premise, and how do I get to the data center? Which leads into the third big component for us, which is data center expansion. Data center expansion is, I got you to the metro, now I need to get you from the metro to the data center with a 400 gig circuit. Today, there are 68 data centers that we have this level of connectivity to in 15 markets. By the end of this year, that'll grow to 139 data centers in 28 markets. So now wing to wing, city to city, within a city, all the way out to the data centers, I've provided that wing-to-wing capability for you to get high bandwidth services in place. And by the way, this is just 400 gig. We're building this out in a way to grow it to 800 gig and to 1.6 terabytes of capacity as the demand grows over time. And so this isn't an end point. This is a stopover point as we're building out that capacity. And then all of it focuses on this. Recognizing that we need access to both the cloud on-ramps and the AI on-ramps that are developed across the United States. Today, we have about 44% coverage of the on-ramps with this level of capacity. By the end of this year, of the existing on-ramps, we'll cover 90% of them. Again, really focused on that enterprise need to be able to get to the large language model capabilities that the hyperscalers have built on top of our PCF network. We need to be able to provide the enterprise networking capabilities to be able to get them there. And so that's the physical layer. Now we're going to talk about the digital piece of this. Network as a service is how customers are going to consume our services going forward. What we're talking about is really a shift from a process where you contacted your salesperson, you put a manual order in place, they did some design work, we rolled a truck, we did a network configuration for you, and at its core, what we're trying to do is really shift that experience to have it be more like a programmable network for you. Traditionally, this has been static. It's been manually procured, and in fact, if you ask to make a change to your service today, the cycle time for us inside is about 20 to 30 days of average cycle time from the time that you start that ordering process till we get it through our systems. That's just not acceptable anymore. And so what network as a service does is it really flips that traditional telecom model on its head. It turns connectivity into a software-driven configuration that can be provisioned, it can be scaled, and it can be reconfigured really as the customer needs to. It will behave like cloud infrastructure. Customers want flexibility. An example here in my last role, I had a large team of data scientists who sat across the United States. And one of the problems we uncovered is their day would start off by them coming in and saying, I need to move a large chunk of data from point A to our premise to be able to get it into the analytical models I'm running on my laptop and get it back out. That was a 2-hour window of time to move data for them sometimes. And what NAS gives us the capability to do is to be able to say, you know what, you're going to schedule that job between 6 a.m. and 7 a.m. And between 6 a.m. and 7 a.m., I'm going to dedicate more of the bandwidth that I have to those data movements so that we have standard times of moving data around the organization to reduce your downtime. So I don't lose 2 hours of a data scientist's day. That's how we're thinking about this. This is what we want the capabilities of the programmable network to be. So as you think about network as a service and you think about Lumen, this isn't just a product shift for us. This is a business model shift. We're really thinking about how we monetize the programmable network, how we improve our capital efficiency, how we align the economics of how Lumen runs to how our customers actually want to buy and use connectivity going forward. So as you kind of anchor the digital story, it anchors off NAS. But the second part that this digital platform anchors off of is Lumen Connect. This is the front end of our programmable network. It's where customers go when they're using network as a service to replace the manual processes and give them on-demand control to change bandwidth, to add services, to modify services over time. This is an evolution from a product we had called Control Center. This is not a reskin or a refresh. This is a brand new strategic platform that will replace that and be the front end of our NAS product. It'll let customers discover the services that are available to them and the capabilities that are on their network today. It'll help them provision new services. It'll help them manage the services they have to scale up or down on demand. We're already seeing in NAS customers who, on a nightly basis, spin up or spin down the capacity they have in their network based on specific needs. We know we're going to see more of that. And we know that it's going to be API-driven, digital workflow-driven. And Lumen Connect is the place where that's going to happen. And rather than me telling you more about it, let's show you a quick video about how Lumen Connect works.
Welcome to the future of digital business, where cloudified, on-demand networking puts you in the driver's seat. In 2026, Lumen is reinventing innovative service management with Lumen Connect, making it easy to quickly scale services up or down, automate workflows, and manage environments with intuitive controls. Get unified insights for Lumen services, along with proactive alerts, guided onboarding, and customizable views for frictionless self-service. Stay ahead with agile service offerings built on an expansive modern fiber network, delivering the speed, security, and reach that innovative leaders demand. Lumen Connect is your springboard into the AI-powered future, with digital control and Cloud 2.0 flexibility that can scale and adapt with you. With Lumen's digital offerings, you get effortless, programmable control, rapid innovation, and a seamless experience at every turn.
So I'd encourage you, when after the meeting today, there's a booth outside. If you want to see more, they'll be happy to kind of share with you a little bit about Lumen Connect and get to see it. This is really what makes NAS economically compelling, because it really helps reduce the manual work that our customers have. It accelerates service delivery, and it allows us to scale revenue without really scaling the costs of how we operate the business at the same time. Now, underneath this, kind of the next layer of that roadmap I talked about is the fabric port. And some of you have heard us talk about this capacity, this capability in the past as Project Berkeley. Berkeley was a development effort that we've been working on for the past year, really to come up with the technical capabilities at the port level to be able to support what we're talking about. Fabric port is the productized outcome of that work, and going forward, that's how you'll hear us talk about it. At the center of the fabric port is a fabric network interface that is a single physical port that can support multiple services. So in the past, in the old world, a port and a service were pretty synonymous with each other, and they didn't have a lot of flexibility. It's what drove a lot of truck rolls, et cetera. Going forward, our technology will actually bring those together where you can have multiple services on that same port. It'll make it more of a user-driven experience. The fabric port also extends Lumen's network to the customer site. This allows them to add services, to modify them kind of locally. It allows us to issue APIs that will allow us to do a lot of the configuration work back and forth with the customer, all without new hardware rolls out to the customer. The important part of the fabric part is really, this is what makes NAS scalable for us. This is how the physical network of what we're doing really becomes programmable going forward, and it's really how Cloud 2.0 for us becomes a repeatable, margin-accretive business. And so a lot of the work we've been doing in the last 12 months is to come up with this fabric port capability. And then the last piece of the digital building blocks that I'll talk about is really the multi-cloud gateway. This is a self-service virtualized routing solution that really simplifies how enterprise get connections into the multi-cloud. My old world, we were in multiple clouds. Each one of those clouds was a separate physical connection that we had to design and build to be able to get into those cloud providers. At Lumen, we really want to eliminate that complexity of managing those individual connections and create a full cloud mesh capability that once you have the fabric port and once you are in the Lumen multi-cloud gateway, it's as simple as a service addition or change to be able to get you access to new clouds, new regions, new SaaS providers and their capabilities over a private network where you're not having to fight with traffic with the rest of the internet. That's how we think about what the multi-cloud gateway should work. We just announced this capability last week. This also opens up for us east-west traffic market I talked about, because yes, this helps with the north-south, but it also gives us a capability to allow those customers now to have a better way to be able to transfer data across those cloud providers. That's all part of what we're building within the multi-cloud gateway. And then the last thing I want to talk about is now go up to the third element of the stack and talk about the ecosystem. When we talk about Cloud 2.0, the core idea is that the network becomes a platform, not just a transport anymore. We're building a programmable digital foundation that lets us integrate best-in-class solutions at the edge, in the core, and across the multi-cloud environment without forcing customers to stitch together the network to make it work. And what we know is there are several partners who need that capability for their solutions to work, for their solutions to be able to scale with the same capacity needs and latency needs that we're talking about. And so that we've kind of created this idea of Lumen validated designs, where we'll partner with other companies in this ecosystem for solutions that take the best of what we're doing from a network perspective and the best of what they're doing from a technology perspective and bring them together. And just two examples to leave you with today. The first is Meter. Meter is really thinking about within the facilities they manage, how do you really unify the local area networking capabilities that they're building out with the wide area network in a single AI-driven experience that really better unifies the connectivity configuration of their customers. The solution that we're working on together as a Lumen validated design really simplifies that. It creates a single place to buy. It uses things like natural language processing to give them the ability to ask for what they're looking for. and it accelerates the deployment of those capabilities for both Meter and Lumen. So that's one example of a partnership that we really believe comes out in the ecosystem. And the second one I really love, because I happen to be responsible for our own internal data, and this is a solution that we're using internally from Commvault. We're using Commvault for our immutable backup system, and the Lumen validated design that we're building with them is really to think about how do you integrate AI-powered data protection directly into our programmable network. They're one of the largest data protection service providers. They are delivering policy-driven backups, this immutable backup space. They're identifying identity resilience, and they're focused on how to build ultra-fast kind of clean rooms for recovery when companies do have losses. When you think about the amount of data that has to transfer at real time to get a company back up and running, those 10 gig circuits aren't going to work anymore. So having a design where we can scale the network to their needs for these backup solutions, that's a marriage that we want to move forward with. And so those are two examples of what the ecosystem looks like. I'll maybe leave you with one last video to unpack what the relationship with Commvault has looked like. With that, thanks very much.
As a CIO, my job is pretty simple to describe and hard to execute. I keep the business running, protect the data, and make sure we can move fast without breaking things. That's why the partnership between Commvault and Lumen matters. We wake up every morning thinking about customer resiliency, resiliency, resiliency. So for me, Vault means safe, right? And so that's what we do at Commvault. We provide a framework for when there is a disruption that customers can recover quickly with confidence. We protect the largest customers in the world, and they range from financial services, healthcare, banking, federal, and technology. Companies can't afford to be down. Lumen's connected ecosystem reduces complexity by validating how solutions work together. The combination between Lumen's edge infrastructure and cyber resiliency framework from Commvault is a powerful combination that is valuable for a customer. Lumen brings global network scale and deep visibility, and Commvault brings cyber resilience, protecting data, identities, and recovery paths. So for customers, that means fewer gaps, faster recovery, and less operational friction. Lumen applied this approach inside its own environment, consolidating roughly 90% of legacy backup platforms. The result was more than $3.5 million in annual savings. That's the real power of the connected ecosystem, and it's the same blueprint we can deliver together to customers in an AI-first, multi-cloud world. The most rewarding part of my day is ensuring that we're actually creating impact and value for our customer.